Start with the name of Allah, the most beneficent and merciful. Today I have came with another problem. The problem is to design a small signal amplifier, which is the basically common emitter amplifier. So the given data about this scenario is actually our input voltage, which is an audio signal or might be any other signal, which have the voltages peak 300 millivolts. So its peak would be 300 millivolts and its frequency would be 5 kilohertz. The other thing is this, that we have load resistance, which is basically 50 kilo ohm, and we need to find out the all biasing resistances of the circuit. So the other thing which is most important, which is given us, is the required voltage gain. This voltage gain 17. So three things we are given: at 300 millivolt peak signal, which is our input signal, and the output load, and the third one is the required voltage gain of the circuit. So supply voltages are assumed to be 12 volt. These might be 9 volt or 10 volt. So there is not standard. While doing the calculations, I did not find any involvement of voltages. So I think these might be changed according to situation. If you have no available 12 volt, you might use the same circuit with 9 volts. It's my assumptions. So I think it should work with 9 volts. But one thing we need to keep in mind is this, that our output voltages which are required, so our supply voltages should not be less than our from our output voltages. Let's make a scenario. If our output voltages in this scenario, we will assume in this scenario, so our input voltages are 300 millivolt peak signal. It will basically peak to peak signal, sinusoidal signal, but I am focusing on the peak because I need to design my circuit according to this peak value. So if we do some calculations, let's assume our 300 this is our peak value, and our voltage gain is 17. So we need basically 5.1 volt signal at our output. Before the simulation, I will explain you about the calculations, and then we will move towards simulation. This is our basic circuit. Actually I have drawn here only common emitter, but these are later on added after this circuit. So the circuit is basically what we were asked. We are given 300 millivolts peak signal, which is basically an audio signal, and our load is 50 kilo ohm, and it is asked us to provide the gain of full circuit, including this and the other two stages also, 17 again voltage gain. So voltage gain is equal to 17, and supply voltages I have assumed 18, and I have built the circuit while using these voltages. Current gain I took 200. Okay, common emitter amplifier voltage gain can be found by the given formula, which is the formula derived formula from the common emitter, because our first stage was the common emitter. So firstly I will discuss about the common emitter amplifier. So it is the basic formula: AV is equal to RL parallel with RC and divided by RE plus RE. So basically here RL I have included it for this stage 50 kilo ohm, because at the end we will this circuit will also facing around about 50 kilo ohm, so I have included. So you can mitigate it or you can exclude it also. So the RL is 50 kilo ohm and RC we need to find it, RE dash we need to find it, RE dash RE we need to find it, and AV is given. So firstly I will find it out RE dash and RE, so that we should have only one variable in this whole equation, which will be RC, and we will easily find through this formula. So what RE is basically the diode internal thermionic resistance. So what is its formula? Its formula is the VTH. VTH means the thermal voltage of diode, and IE it means the current passing through the diode. Actually the diode means here is the common in configuration of common emitter or common diode, common collector or common base. In every configuration our base emitter junction should be forward bias. So whenever it will be forward bias, it will act as a diode. That's why I am telling you here about the diode. So RE dash is equal to the V thermal divided by IE. IE basically the current of emitter. So VTH is you may say that a standard value. This is 26 millivolt, and IE could be find out. How? We know that IE is equal to IB plus IC. I emitter current is equal to I base current plus I collector current, and I collector current is assumed to be 100 milliampere. So base current could be find through this relation IB equal to IC divided by beta. So after this IB is found, and which is became 5 milliampere or 500 microampere. After that IE is found 0.5 plus 100.5 milliampere, and after finding it out we can easily find out the RE dash and RE. How? Let's see. According to the rule of thumb, our emitter resistance should have at least 0.6 volt drops according to the stability point of view. So I have assumed 0.6 volt drop across the emitter resistance. So we know the emitter emitter resistance voltage across, which are basically we have taken 0.6 volt, and IE is found earlier. So here RE could be found, which became this 6 ohm. Right now RE basically the thermal resistance of diode could also be found, because VTH was 26 millivolt, and so this will be 0.2587. Now putting these all values in this formula, and by simply doing some mathematics, you will get the RC value of this. After that, finding out the R1 and R2, which are basically our voltage divider bias resistances to bias the base of the transistor. So base voltage is what will be voltage is 0.6 volt are the emitter voltage, emitter resistance voltage, and 0.7 are the forward bias junction voltage. These will combine will become 1.3 volt, and now here again we will assume one resistance and find other resistance. So I am assuming R2, which is basically the second resistance. If you see the here, this is R2. So what will it become if I have assumed to 500 ohm? So putting these values in this formula, R2 is known 500 ohm, VB is also known 1.3, and VCCs are 18 volt. so I will get the value of R1. So these were up till now, these were the calculations about common emitter. Now I will start the calculations about common base, oh sorry, common collector. So in case of common collector, we will first need to design the R1 and R2, which are basically voltage divider biased configuration of common collector. So in this ways, again our desired voltages at output are 10 volt, and 0.7 volt are the drops of the diode forward bias. So again, using this formula which I have used here, same formula, and assuming one resistance, the R2 assumed I as 10k, the other one could be found as 6.28k, 82k, sorry. And RE could also be found, RE basically V across RE divided by current through RE, and I have assumed the current as I was assumed earlier, 100 milliampere, and the voltage across the RE should be 10, so this will be simply 100 ohm RE. Now I will move towards simulation. This is the simulation I have saved into your account with the name of small signal amplifier. You can access it in your account. And this stage, the first stage here where my cursor is moving, this is the common emitter amplifier stage. The second stage is the common collector amplifier stage, and third stage was the only adding a diode to make it half wave rectifier. Okay, only adding a single diode. So right now all the values calculated from there are put it into these resistances, and right now I am just simulating because the video is already become very long. This is our input signal, blue one. If you see its peak, it's right now 299.55, although it is closer to 30 milli 300 millivolt. And this is our rectified, half wave rectified output. Okay, and if we want to see the additional one more output, so we can see it here. Okay, actually I just want to, okay, if you see, this is our input signal and this was our output signal across the common emitter amplifier. You can also see the phase shift of 180 degree. Actually here it is not prominent. For that I will be needed to remove this signal so that I can see only two signals. Instead of this, I should have here. You may see that there is actually exactly 180 degree phase shift, which our common emitter amplifier does. Our common emitter amplifiers does a 180 degree phase shift, and the other thing is this, that our input signal is this and output signal is this, which is amplified through the gain of 17%. Right now I will add our the main signal, which is half wave rectified signal. So I will add another voltage bulb so that all the signals should be displayed on a single window. So here you can see all the results. You may see that our rectified output voltages are little bit minute down from our actual voltage. These are because to our diode voltage drop. Okay, I hope you will